we're going to work on further linear equations. Okay, and it's going to be given by this basic formula here. What we're going to be working on is we're going to have a given set pattern of numbers or values, and we're going to try and find the pattern by giving a rule or an equation to describe that pattern. Okay, and this is what we're going to be using. So where A and B will be some numbers or values. So let's start off by looking at question 1. So we have this pattern here. So 2, 5, 8, 11, 14. So we have a nice sequence of numbers there. And looking at part A, we're going to try and find a formula for the nth term, Tn. So if we look at what we've looked at before, my linear equation is just simply given by this. And what we want to do is to try and find the values of A and B, and that should be my equation or my formula. So the first thing I'm going to look at is the pattern here, and you can see that each number will go up by 3 each time. Okay, what does that mean? Well, it means that my multiplier will be 3 in this formula. So in this formula, that is referring to A. So A equals to 3. So I'm just going to replace that and rewrite my equation. So now what I want to do is try and find B, because I don't know what B is. Okay, so to find B, I'm going to have a look at my set of numbers here, and note that when n equals 1, my value of the number would equal to 2. So what that is talking about, what these n's are talking about is the terms here. So for example, this is n equals 1, 2, 3, 4, 5. So with the number of terms, okay, and that will refer to the actual value. So when n equals 1, the first term, it will be 2. Okay, that's what we're going to look at here. So when I sub n equals to 1 and t equals to 2, we're going to have something that looks like this. So what I'm doing is just replacing this t with a 2, and that n is going to be replaced with a times 1. Okay, this way we can find b. So I want you to simplify it down. Okay, and we'll note that b equals to -1. So let's go back to the question. We're still going to try and find the formula, okay, which is going to be given by our equation. So I want you to rewrite b into the equation. And we should have Tn equals to 3n minus 1. Okay, and that's my formula for part A. Now looking at B, we're going to have to find the 10th term. So the 10th term, so there's term number 1, 2, 3, 4, 5, and I'm going to try and find the 10th one. So if you look at part A, well, we have a formula for it. Okay, then I can just sub in n equals to 10. Okay, because n refers to the number of terms. So if I simply put n equals to 10 in there, it will be 3 multiplied by 10, take away 1. Okay, and that will be my 10th term. Okay, it has a value of 29. Now looking at part C, we're going to have to find the term whose value is 44. So somewhere along this pattern, we're going to have the number 44, and we're going to try and find which term that is. So in other words, we're going to try and find n when t equals to 44. So again, we're going to have this formula, and I'm going to sub in 44 into t. So t equals to 44, and I'm going to try and find what that n is. So let's simplify this equation down. I'm going to move 1 to the other side. Okay, let's calculate it. And we find that n equals to 15. So the actual answer to this question is, the 15th term has a value of 44. Okay, and that's how we answer these questions. Now looking at question 2, we have this pattern of students sitting around a desk. So we have students arrange themselves around desks ready for group work in the classroom. And the seating arrangement for n students at d desks is shown. So for example, this is one desk, okay, so d would equal 1. And if d equals to 1, then how many students are there? Then we have 6 students, okay, which is referred to n. So let's try and answer the questions. Now part A, it says find the number of students who can be seated around a row of 4 desks. So again, this is desk 1, these are 2 desks, 3, and we want to find when there's 4 desks, how many students are surrounding it. So it's going to look something like this. And from here, we can just simply count how many students there are. Okay, so for 4 desks, we know that there are 12 students. So I want you to just simply count them. Now moving on to number B, list the numbers for the first 8 desks. So what is that saying is this is desk number 1, 2, 3, 4, and up to 8 desks. How many students are there on each desk is what we're saying. Okay, well we know the first one is 6 if we just count it. And the second one, I want you to count it as well, it's just 8. And this one for 3 desks is 10. And for 4 desks, we found in part A is 12. Okay, we can see it just goes up by 2 is the pattern. I'm just going to keep going up by 2 until we have 8 of these numbers. Okay, so the numbers for the first 8 desks have 6 students, 8 students, 10 students, and so on. Okay, so it's the same question, but we're going to have to look at part C. So in part C, it says to find a formula that relates the number of students N to the number of desks D. So pretty much what this is all trying to say is we want to find a relationship, or we want to find a formula, okay, that describes this pattern. Okay, and we're going to have to use the variables of N and D. Okay, so we can note that we found that pattern that it goes up by 2 each time. So what does that tell me? Well, if you look at before, we know that the multiplier then would equal to 2. Okay, so the multiplier in this formula is simply 2. Well, how does that help us? If you take a look at our linear equation again, N equals to 2D plus B. So that 2 is replacing the A. So remember our linear equation was equals to AD plus B, and we found out A equals 2, so I'm just going to replace that into the formula. So we have this formula, and we want to find B now, because that's the value that we don't know. So I'm going to have these two values. So I know that when D equals to 1, N equals to 6. So what that's describing is, well, for the when we have 1 desks, we have 6 students. Okay, so if I put that into my formula, it should be true, and it should work. So that's what I'm going to do. So in that formula, I'm going to replace D with 1s, and my 6, I'm going to replace in the N's. Okay, so let's try and simplify this down. And my B equals to 4. So let's rewrite my formula with all my numbers. N equals to 2D plus 4. Okay, so that's the formula that describes this pattern here. Now, looking at number D, we're going to have to find the number of students that could be seated around 21 desks. Well, 21 desks, it sounds very hard that we can't really draw 21 desks, but it's very useful because in the previous question we found a formula for it. Okay, so 21 desks means, well, D should equal 21. And if we simplify that, we can find how many students there are. So let's try that. So again, I'm going to replace this D with 21. So it will be 2 multiplied by 21. So I want you to calculate this. Okay, and we'll have N equals to 46. So around 21 desks, we have 46 students surrounding it. Okay, so that's how we answer those questions. Now we have final part E. It says a class has 31 students, then how many desks are needed for them? Okay, so it's a bit of a reverse question. We know how many students there are. We want to find out how many desks we need. Okay, so N equals to 31. So I'm going to put N equals to 31. So instead of N, let's just put 31 in there. So 2D plus 4 equals to 31. Okay, let's try and find what D is then. So I'm going to move 4 to the other side. Let's calculate it. Okay, if we divide 2, okay, we found that D equals to 13.5. Okay, but we still want to answer the question. How many desks are needed? We can't really say, it's going to be very hard for us to say we need 13.5 desks. So I'm just going to say we want enough desks. So I'm going to say we need 14 desks for those 31 students. Okay, and that's how we answer these sort of questions.